So here's one of our last demonstration problems. The reason why I picked out this one is because the other ones just had numbers on top. So this one has letters on top and at the bottom. Again, it's still under add and subtract. I understand adding and subtracting is the hardest of all the things that you do with rational expressions. Multiplication, division, and simplifying is much easier than addition and subtraction. But if you go through the 7 steps, hopefully you'll be okay. So because for addition, again, look at your denominators. They have to match for us to do any addition or subtraction. You can see 4y plus 2 and 6y plus 3, the way it's written, no match. So we need to find an LCD. When we have no match, we told you to do an LCD, look at the denominators only. See if you can factor out the denominator. So here it's 2 terms. So do not do a tree diagram. Do not do 2, 2, y, 2. We're not doing that. You have to see, is there a GCF? And for 2 terms, do you have difference of squares? We can see that we do have a GCF. They're both even numbers. There's a hidden 2 in here, remember? 4 is 2, 2, y. So they both have a 2 in common. So we can take out a GCF of 2. And then our leftovers, when you divide both by 2, will be 2y plus 1. Looking at the leftovers here, remember we have to check to see if you could do difference of squares, and I can say no, because we have a plus sign. Automatically you can't do difference of squares. Now let's see if we can factor out this denominator. Okay, again, it's a binomial, so no tree diagrams. When it's a binomial, always ask yourself first, is there a GCF? And you can realize there's a hidden 3. Remember, 2 times 3. So they both have a 3 in there. So when you take out a 3 out of each term, you're going to be left with 2, remember 6 divided by 3, 2y plus 1. Now notice, binomial, so we want to check to see if we have difference of squares, but because of the plus sign, can't factor it any further. Now that we factor each denominator out, then you're going to write your LCD list, and then write down each of the different types of factors. So monomial 2, that's one type, put it in your shopping list. 2y plus 1, binomial, that's a different type, it's different than plain 2. Then let's go to this. Do I have a 3 in this list? Nope, that's a different type. So each different type you're putting in the list. Do we have a 2y plus 1? Already in the list, so don't duplicate that one. Now that we got the different types, we need the amounts, so we do the versus game. So for 2's, there's 1 here, but 0 here. Remember, this 2 doesn't count. This is binomial 2 land. This is monomial 2. There is a difference. So 1 versus 0, we need 1 of them. For 2y plus 1, 1 here, 1 here. Remember, it's a tie. You're playing the versus game. Okay? 1 versus 1, who wins the race? It's a tie. So the 1 will be the winner. And then for 3's, there's 0 here, 1 here. 0 versus 1, 1's the larger amount, so we have to put it as a 1. Remember, these have to be a number. They cannot be zeros. Now that you found your LCD, raise each of your fractions. Now, to save a little bit of time, why would I want to keep it as 4y plus 2 when I can use the factored form? Because when you do raising, one of the steps was factor each denominator out. So I don't want to keep this if I know it factors out as this. The reason why I want to use the factored form is because it makes it easier to see who the extra piece is, if any. So if we look, you have a 2, have a 2. 2y plus 1, 2y plus 1. So you're missing that extra piece of 3. So remember how we have a box on top and a box on the bottom? You want to put the 3 at the bottom because that's the extra piece. This times this gives you this. And whatever you do to the bottom, you have to have the same thing on the top box. So y times 3 is going to be 3y. You can see when I found my LCD, I didn't bother multiplying 2 and 3 and get 6 and then distributing. Because again, if I leave it as each individual factors, it's easy to compare to see what the extra piece is. Let's do the other fraction to see if we can find an equivalent. Don't use the 6y plus 3. We know it factors out. Let's use the factored form. Makes it easier. And then our LCD, which is this whole thing. Draw your box. So when you compare this to this, you can see the 3 and the 3 are still there. The 2y plus 1 and the 2y plus 1 is there. But the 2 is the extra piece. So the top is 6y. Now that you have those two pieces, we can use these fractions, the equivalents. Why would I want to use the equivalents? Because they match. Okay? I'm going to erase to make some space. We know this was the addition problem. So let me just do 3y is the 2, 2y plus 1, and the 3, plus 6y, 2, 2y plus 1, 3. Do not try to reduce any of these guys. If you start trying to reduce, you're just going to get the original question. You're not going to get an answer. So remember, once you got this to match, remember what we tell you to do? Match, match, but there are two of them. Instead of writing it twice, only write it one time. Then the tops, we told you just to keep them separated, put parentheses around them so that we can rewrite it. 3y plus 6y. Now, a lot of you can probably look at that and say, it's a plus sign, so even if I distribute, I'll still get 3y plus 6y. So a lot of you will ignore the parentheses and say, well, 3y plus 6y is 9y. Okay? Remember, we're collecting like terms. Y's with y's does not give you y squared. Okay? You keep the same variable part. Single y stays single y. This was a positive, this was a positive, that's why we added to get 9y. The last thing that you have to do is see if you can simplify this. Now the bottom's already factored out, so I don't have to do that. But the top, it's a monomial. Remember, monomials is the only one that I say do a tree diagram. So that's 3 times 3 for 9, and then the y on the side. So notice we have monomial 3 on top, monomial 3 at the bottom. Okay, so this and this cancels out. So our final answer is going to be the 3y, which is left over, and this, which is left over. If you wanted to distribute this out, you can, but I just leave it like this. This is fine. So this would be your answer.